All right, so we are starting a new chapter today, chapter 6, and the first topic is all about vectors. So if you've taken physics or if you're in physics now, that word should definitely ring a bell. All it is, a vector just is a way to represent a magnitude, which is another word for length, and direction. So the most commonly used vector is velocity. So velocity is just a speed with a direction. So if I say I'm moving northwest at a speed of 50 miles per hour, that's the velocity, which can be represented as a vector. So if I want to actually graph a vector, I can have it start at 0, 0 and run through that nice point at x, y. So the vector would be what I have represented in red. It looks almost like a ray in geometry, where you have a clear starting point, but it goes on forever in a specific direction. So component form is the next big thing. What it looks like is almost a coordinate point, but it represents the horizontal component, meaning how far I traveled out, left or right. My pen went crazy. And the y represents the vertical, how far I moved up or down. So if I want to find the component form of this vector that I just graphed in red, well, you can see that I moved to the right x units to get from the origin up to that ending point at x, y, and I moved up y units. The last thing is this magnitude. All it is the length of a vector. So you can see here, the vector almost looks like a hypotenuse in a right triangle. And because it is the hypotenuse in a right triangle based on the way we drew it, we can find the length of it using the Pythagorean theorem. So x squared plus y squared equals, call it the hypotenuse squared. And to get the hypotenuse by itself, you take the square root of x squared plus y squared. So the horizontal component squared plus the vertical component squared. And we represent magnitude with that v with almost absolute value looking bars next to it. So anytime you see the absolute value bars inside or outside of v, we're just talking about magnitude. So this guy, while it is pretty obvious using the Pythagorean theorem, would be something that's definitely going to come in handy. So to use these few things, again, hit pause if you ever need to. Make sure you're copying down some good notes since I didn't post them on Weebly. The next thing is to find component form, magnitude, and what we haven't talked about yet, the direction angle of a vector. So to find component form first, all we're really looking for is how far to the left or the right I went and how far up or down I went from what we call the tail, meaning that starting point, the base of that vector, to the head, basically where I'm heading, the end of that vector or the ending point, call it. So to figure it out, we can take what we call the head minus tail rule, and it's pretty intuitive. And you can even do it in your head. All you're doing is you're taking the horizontal component of the head, so 7. You're subtracting the horizontal component of the tail, and then you do the same with the vertical. So 1 minus 8, which means I traveled to the right 5 and down 7. Think about why that makes sense. To get from 2 to 7, I had to move to the right 5, and to get from 8 to 1, I had to move down 7. So that's all the component form is. How do you get from the tail to the head, the starting point to the ending point? Just realized use a parenthesis instead of the fancy bracket that we need for component form. The next thing is finding magnitude. So remember magnitude, we represent it with that v. To do it, we take the square root of the horizontal component squared plus the vertical component squared. Because this is a right triangle that we just created, we're looking for the hypotenuse. So we have the magnitude equals 25 plus 49. So that vector has a length of root 74. You can leave it just like that. Now the last thing it asks for is the direction angle. So think about this. If we stepped away from vectors for a second and I asked you to move to the right 5 and down 7, we'd be in quadrant 4. Right 5, down 7. So I want to draw a vector from 0, the origin, out 5, down 7. I'm looking for this little angle, so the direction at which that tail starts and how it gets to the head. So to find that little angle, think about all the trig we've done. If I have the opposite and I have the adjacent, tangent will help me find it. So the opposite over adjacent, and to get that angle by itself, you take the inverse tangent. When you type that in your calculator, we want to always be in degree mode this unit, so make sure your mode's in degrees. Inverse tangent of -7 over 5 gives you -54.46 degrees. Now I'm fine if you gave me the negative angle. You could also give me the positive, which means you're going to 360 degrees, just 54.46 degrees less. Oops, goodness. Here we go. So you'd be at 305.54 degrees. So I'm fine with this or with this. You don't have to give me both. All it means is that I move to the right 5, down 7 with a magnitude or a length of that vector at root 74, and the direction angle was just 305 degrees. So you're moving basically southeast. Here's another way to represent vectors. We're still going to find the same thing, but now they don't give me the picture. So if I plotted this myself, I have 2 points that I know. Point R is at 4, 3, so call it right here. And point S is at -1, 6. So notice this notation. They want us to start at R and head towards S. So when I draw my vector, R is going to be my tail, and S is going to be my head. So to find the component form, you take the head minus tail, so the horizontal components first, then the vertical, head minus tail. You end up with a component form of -5, 3, which makes sense. You moved back or to the left from 4 to -1, took you 5 steps, and then you moved up from 3 to 6, took you 3 steps. We just created that right triangle, which is going to help us find our magnitude using the Pythagorean identity. Square root of the horizontal squared plus the vertical squared. So you'd end up with the square root of 34, meaning the length of that vector is root 34. I did it again. You guys are probably yelling at me over the video. All right, the last thing is to find the direction angle. So if I moved back 5 and up 3, you'd be in quadrant 2. Horizontal component -5, vertical component 3. If I'm trying to find this little direction angle, I'd use tangent again. I know the opposite and adjacent. So use inverse tangent. And you get an angle of -30.96. Think about why that makes sense. Inverse trig is restricted for tangent quadrant 1 and 4. If I want a negative value, of course it's giving you an angle in quadrant 4. But quadrant 4, remember, it's just the reference angle with a negative slapped in front. So I want a 30.96 reference angle, so I can use that value I just found. That's my reference angle in quadrant 2. To find the larger angle measured from 0 to that vector, you're going to take 180 degrees and subtract that value to get your rotation angle of 149.04 degrees. All right, so that tells us that basically we're moving northwest. All right, the next step, or the next few things go pretty fast. All we're doing is we're adding, subtracting, and multiplying vectors. So when we add, we just want to add the horizontal components. So you have the 2 plus 3. Vertical, do the same thing. You're adding them. So we get a 5 horizontal component and a negative 9. So adding the two vectors gives me that horizontal, or that component form. Same thing with subtracting. You're starting with V, so take the horizontals, subtract them. Starting with V, subtract them. You get a positive 1 and a negative 1 component form. With scalar multiplication, you're just multiplying the components of U by 2 and then subtracting the components of V that have been multiplied by 4. So it's basically you're just distributing them. 2 times 2 gives you 4. 2 times negative 4 is negative 8. 4 times 3 is 12. 4 times negative 5, negative 20. And then you're subtracting. Notice how I just multiplied the positive 4 instead of negative. You could multiply the negative, but then this would change to a positive. So now you have 4 minus 12 and negative 8 plus 20. The double negative creates the positive. So here you get negative 8, positive 12. That's your component form. The last step is what we call resolving a vector. All we're doing is we're finding the horizontal and vertical components of a vector. So the first guide they give me a direction angle of 40 degrees. So the same way you would in trig, 40 degrees is in quadrant 1. And they also give me a magnitude of 12. So that means the length of the vector is 12. So now we just have to find the horizontal component and the vertical. So to do it, we can use trig. If I want to find the adjacent and I have an angle and its hypotenuse, I can use cosine. Adjacent over hypotenuse. So in your calculator, you have 12 times the cosine of 40. You get an x component of 9.19. And to find y, that's the opposite to that 40-degree angle, so I'd use sine. So I have 12 times the sine of 40, which gives me a vertical component of 7.71. So resolving a vector, I want the component form. So 9.919 is your horizontal, 7.71 is your vertical. Make sure you have the good brackets. And the last one, they're giving us an angle of 115 degrees, which we know is in quadrant 2. Here's 115, which means this guy must have a reference angle of 65. They give me the magnitude is 6, so I need to find the x and the y component. You're in quadrant 2, so that x will be negative. Do the same thing. Cosine of 65 is my adjacent, which we can just say is x. Don't worry about the negative. We'll slap that on at the end. Over 6. So you have 6 times the cosine of 65, 2.54, which we know is negative. And do the same for sine to find y. So 6 times the sine of 65 is 5.44. And it's in quadrant 2, so y is positive. So your component form has a negative horizontal component, but a positive vertical. So we'll recap tomorrow. I know we went fast. Feel free to watch the video again or hit pause a few times if you need to go back. But you should have good notes and be able to take a good stab at the homework.